So we have a twofold program today. So first part is really all of applications and tools. Second part is RVM-CSI that we already alluded to a bit. And after that, lengthy, I hope so, lengthy Q&A, given that we barely ever get everybody in a room to talk to these days. So since Stefan already said we are the survivors of the split, so to say, the continuation. So the applications and tools HC is really what was the software HC before. And we have handed off some of the hairier topics to Aaron. Thanks, Aaron. And our focus really is just in fostering the software ecosystem and getting ready to drive the various applications out there and get adoption up. So we've inherited the outreach to a number of upstream projects, and still have the tool chains responsibility. And most of all, we have governance over tool chains, performance libraries, and ABIs. So the ABI standardization that's been going on is part of what we do. And we do all of that, of course, in close cooperation with the privileged software HC. So just to come up with a slightly used quote. This is our real mission. So delivering silicon that isn't supported by software is a bug, and applications and tools is mainly focused on making sure that everything we're doing out there is supported, that we have a way to get custom extensions supported, and also drive the overall enablement for a number of extensions that are being defined today. So in terms of the organizational growth we've gone through in 2022, there's a couple of key topics that have been addressed. So performance modeling is in our scope, so is performance analysis. You will be seeing a lot of more presentations about that here at the event from the actual leaders of those groups. So performance modeling is trying to build up a RISC-V specific framework for cycle accurate modeling. Have all of the common blocks done and allow people to just plug in their specific microarchitectural models, standardize the trace formats and whatnot. So the second group, which is performance analysis, is led by Beeman, who also has a tutorial, I think, or at least a presentation later this week. And they are looking both into capturing performance events and visualizing them. So both of them are pretty critical SIGs for us to close the gaps and define an end-to-end performance flow for RISC-V. So consider VTune on steroids. So you run it, you characterize your applications, you do some analysis, and you put that into your next generation model in order to see what improvements you can do. Another key SIG that we established this year has been hypervisors. So the hypervisor SIG has been taking over all of the software side governance for virtualization. One of the big achievements on their side for this year has been that they have looked into all that's necessary for nested virtualization. Nested virtualization is key to a lot of the hyperscaler workloads, given that customers might just jump in, get themselves a virtual machine, and then run virtualized content on there again. So they took care of doing the proof of concept. I think Anup has a presentation this week on nested virtualization, and we also have a tutorial on virtualization in general. And then there's the RVM-CSI SIG. Chris will be speaking about that a bit more in detail later on today as part of the segment. And he'll walk you through what we're doing there. So RVM-CSI is our answer to what ARM and others did in terms of having a hardware abstraction layer and standardizing the hardware abstraction between multiple embedded platforms. So RVM is for RISC-V microcontrollers, and CSI is the common software interface. So this is really a portability aid, because we've realized at some point last year that it's quite futile to try to standardize platforms for microcontrollers. So we can't really determine what ISO profile it should be, because everybody might need something else. We can't determine what peripheral blocks they have, and at the same time we still want to offer some sort of portability layer that allows people to move their applications from one device to another. And finally, we have the PS API SIG, TG, which just finished their work a couple of weeks ago. So we now have a ratified PS API, and they will be starting again next year for the next generation one. So in terms of growth, the software growth is quite astonishing at the moment. So we're bringing in more and more projects, we're bringing in more and more groups, and having more and more people active there. So RVM-CSI is going to span a task group to actually write a specification next year. AI/ML has been or had been merged with graphics due to the lack of independent leadership for a while. And they are going to start up being their own standalone group. We got quite a few nominations for leadership there. We have a working action plan that includes both matrix multiplication and going beyond that, basically leapfrogging what other architectures have by either looking into neuromorphic or something else. We're going to inaugurate a QEMU SIG in order to have a closer relationship between the QEMU project and RISC-V. It's the main emulator that most of us use today anyway. We have a great maintainer there with Alistair, and this is going to be a SIG to coordinate the outreach to that project and help us develop some RISC-V specific content in order to get people to use it better. And of course, performance modeling is going to spawn reference models TG. Hopefully some open source reference models. Alibaba already reached out. They had open sourced the RTL of some of their older cores, and they are considering to provide performance models that match these open sourced RTL cores. And we have a heavy lift on the PS API side ahead of us. So I'll have a slide on that later. In terms of getting in touch with our groups and what they're doing, there's a couple of tutorials scheduled this week. So performance tools is here, both of the chair and the vice chair giving a tutorial on using the performance modeling tools in Sparta. We have a tutorial on spike usage this week with Eop Chen, who's also the chair of the RISC-V vector intrinsics. Toolchains has a tutorial on the entire flow, so basically building it, extending it, and introducing folks to the components that they are governing. And we're having a pretty good virtualization tutorial planned later this week by Sandro. And please attend those if you can, reach out to the folks, and this is a very good way to get involved in these areas of RISC-V. So to wrap up the report on what we did this year, the key achievements from software this year have really been the PS API stuff. There's an updated specification, it's ratified. We now also have a gap analysis for next year. That document is publicly available, referenced from the PS API group, and they will try to address as many of those gaps for next year, but for next year, the plan with PS API is to really time box. So we will address as much as we can, but we will also make sure that we have a new PS API revision by this time next year. And if not everything can be addressed, some things will end up on the to-do list for the year after. Managed runtimes has gotten their OpenJDK port merged early in the year. Android SIG has, you might have seen the announcement with Android coming to RISC-V, made great progress towards really bringing Android there. We have good participation by Google engineers now within the Android SIG. So it's not just us anymore, but we are really interfacing with the AOSP project. People from the AOSP project are attending the meetings, and that is really a big step forward for our software readiness. And finally, the performance modeling SIG, as I mentioned before, has open sourced the Sparta framework. So a big thanks to Sci5 because they made that possible. Knut Lingard, who is the principal author of Sparta, is one of their engineers, and this helped us address a couple of issues we had around Gem5. I don't know who attended the meetings, but middle of the year we did have a bit of a crisis around the patent situation in Gem5, and that really prompted us as a RISC-V community to move to Sparta and build up our own framework. So before we go into the details on CSI, the outlook to 2023, I would appreciate participation from all of the organizations here, because these are key topics for our ecosystem still. So there has to be a major PSAPI update again. We have a very clear list of the gaps and the future improvements we're planning to close. One of them is getting a vector API defined. We're having some issues around relocation entries that need to be addressed. An embedded API is one of the things that we've basically been where we've just been kicking the can down the road for a year and a half now. So there is a proposal for an embedded API now. That should be reviewed. We need to create a consensus of where we want to head in that area, and then get that codified and put into a future revision of the API. The large code model is still missing. So at this point, we have a huge address space, but we can't really have binaries that are equally big. And of course, on the Atomics API, there's a number of open topics that need to be addressed. So as of today, we're actually having multiple Atomics APIs depending on whether you look at the kernel, LVM or GCC. And one of the key efforts for next year is to unify all of these and make sure that we end that fragmentation, given that it can cause a bit of pain. So at this point, I'd like to do a deep dive, and Chris, if you want to take over. So we have RVM-CSI as one of the areas that is important to us and that needs a lot of help. And Chris is the chair of that group, and I'll pass the phone and the microphone over to him.
Thanks a lot, Philip. Thanks for the opportunity to plug what we're doing a little bit. Actually, perhaps I could start by asking, before it was mentioned today a couple of times, who here has heard of RVM-CSI? Hands up. Oh, yes, maybe a quarter. So, yes, partly I wanted to do this just to raise awareness a little bit. We are quite new. We're just getting off the ground. So, you know, as mentioned, Philip's explained a little bit about what it is really. So we've heard earlier on a lot of sort of hand-wringing about this problem about binary compatibility distros. And so we've got a slightly easier problem. So the RVM-CSI is targeting systems where we assume that all your source is built for a specific platform. So we don't have to worry about actually binary, compatibility of binaries between platforms. But we want to create, we want to make it very easy to write source code that is portable between platforms. That's the idea. So as mentioned already, I think it stands for RISC-V Embedded Common Software Interface. And it's primarily a hardware abstraction layer. There's probably some other aspects to it. You know, we probably need to define board support packages in a format that board vendors can supply a package for their platform. But the idea is you've got an API there which people can write their source code to that abstracts the details of the platform, and then a vendor for a particular platform would produce a package that will then easily allow that software to be ported. So we're targeting particularly either bare metal systems or sort of RTOS type systems, embedded systems, not really systems with complex OSs like Linux that have obviously got their own ways of dealing with these things. And as already mentioned as well, we're filling the space that in the ARM world is filled with CMSIS, so the Cortex microcontroller software interface standard. So we've just started up this SIG. So is that SIG TG structure. So the SIG is looking after the long-term view and has ownership of probably a number of task groups underneath it doing very specific bits of work. We've already just started up the first task group to look at sort of version 1 of a specification for this. So I've mentioned there a couple of other solutions in this space. So we've already got a bit of sort of fragmentation going on here, which is really why we'd like to, we need to get going on this, because, if you're trying to define a standard for portability, the last thing you want is lots of different disparate solutions. And also some of these solutions are really designed by a particular vendor, wanting to make it easy for people to build for their platform, but not necessarily thinking about the bigger picture of, can I produce some software that works across a whole range of platforms? I've mentioned 3 there. Actually, if people do know of others, I'm quite interested, so we need to review what's in the space. You can always go on our mailing list there and tell me about more that's going on. So it helps to get it right if we know what's out there already. We are starting with the C API because that's obviously probably the most popular choice at the moment. But we are also keeping it open that this is not a single language thing. We want to potentially support for other languages in future. Obviously, Rust being one that's in mind. So we're defining a sort of single source of truth from which different language APIs can be derived. But the first tasks group will be looking at C in particular. So key aims, I guess some of this is pretty obvious, but just to spell it out. So, software writers can have more confidence about portability, and that in itself obviously important to drive adoption and so on, make things easier for developers. Chip vendors can be motivated to work to a common interface in producing sort of a board support pack. And SDKs can be more easily cross-platform. And most importantly, if we can get multiple stakeholders involved in this, we've got more chance of getting it right. It's not defining APIs is not easy. It's not something that's easy to get right. You have to anticipate what people might want to do, which is not always easy. So the more input we can get, the better on it, really.
Actually, you should state that this is going to happen one way or another, and given that the participation from the membership has been low, 4 companies.
Partly why I wanted to get some more exposure today is that we haven't had a lot of involvement, and actually some of the involvement we have has been a bit passive. People are kind of listening on, and I'd be quite happy to go and put my ideas forward, but that's not going to work if it's, I don't have all the answers. So, it would be great to have. Yeah.
So what's going to happen is we're going to standardize this eventually. So this is on Rails, this is on a roadmap, and we're not getting as much input from the wider audience as we would like in order to feel comfortable. So this is really a call for everybody to review what's going on and bring the input to the table, because otherwise we might end up with a specification that doesn't reflect everybody's desire of this.
Yeah. So some of the APIs, if you look at some of those others, they're quite low level as well. So my view of the thing is, you don't want an API for a click or for a click or something. For interrupts, you want something higher level that's just let's enumerate the interrupts in my system, and let's have a function for registering a handler for them and something for routing them, but not talking about I'm dealing with a click or whatever it is. Similarly, I have these ideas about can we have maybe not just a UART interface, but a more generalized thing for let's get some text out of my system, and it can use build options to route to either a UART or semi-hosting or a circular buffer or nothing if I haven't got all those. My view of it is that it could be a bit higher level than some of the things that are out there at the moment, but actually there's always that compromise that writing something higher level in abstraction can be more useful, but it can also be more difficult to get right. So, getting that level of abstraction right is one of the other challenges that we've got here. So, yeah, those are just the list there. I won't read it out, but some of the things that we've identified so far as being the important things we'd like to tackle for this version 1 specification that we're setting up the task group for. But right at the moment, it's all up for grabs. If you want to get involved and if you've got your own ideas and input, then that's what we're after. So, that's my message, really. We're very welcome to get involved and help us out on this. I think that's all I've got. Thank you.
So let's start the Q&A. Seems like we have a bit of a tradition in the Q&As now after the privileged group. And I know I'm getting a question regarding the ABI.
I was supposed to go to talk about the HAL actually, but the on the PSABI, one thing you're missing is the vendor-specific relocations, which is a small thing and has been sitting there for 2 years and is blocking stuff. On the HAL, I'm glad you're running with it. I'm glad you've got Victor working with you on that. And the Open Hardware Group, which is one of the bodies trying to implement RISC-V, started a project to do a HAL and then realized it was hard and very sensibly, through Victor's leadership, realized we should wait for RISC-V. But what that means is you have got some material about requirements that you can probably pick up, but Victor should have that. I'd add one more to your list because I will forget to send you an email, which is the Intel NIOS 5 HAL, which might be a good starting point, A, because it's RISC-V, and B, because it's based on the NIOS 2 HAL. It's had quite a few years to shake it down. Secondly, on CMSIS, that's actually 7 different systems, if I recall. And I think probably the issue we got into was breaking down what is it you want to do. And I think you've described 2 things here. One is abstraction of the board support package, okay? And the second, I think, is generic device driver interfaces, even if it's only the UART. And the only thing I'd leave you with is just to see how important this is, because one of the things we got was, well, it sounds like a good idea, but actually the number of people who want it is very small, because there's always the trade-off of the flexibility of I can move to a new version of my chip easily versus if I make things generic, I'm paying off a trade-off either in performance or code size because they're generic and not specific to my processor. So I don't know what the answer is. I'm just giving you lots of questions, really.
Yeah, well, these are all good reasons why we need more input, in a way.
Oh, and we have the same problem with it. It's a specialist field. It's a hard field and it's specialist, and there aren't many people who know what they're talking about, and I'm not one of them. So it's a real struggle.
Those
Good luck.
2 tips on the existing ones are useful. Thank you. Yeah, I think you're quite right.
No, it's okay. I need the exercise.
And Jeremy, it's kind of good that you said you're not one of those people, because I was about to remark that the meetings are in a UK-friendly time zone.
Yeah, I was just going to build on Jeremy's question about the CMSIS, because as he said, there are about 7 components to it. I was just wondering if there's any other aspect to address some of the other components, like the DSP or the ML components and things like that.
So I'll take the high-level answer, and Chris, feel free to reach for the microphone if you want to override me. So the goal at the moment is to do this extensible, a bit like we're having our core functionality and then the extensions and mirror that. So bring up a system, have the basic functionality like interrupts, a bit of I/O in there, and then add DSP functionality and then as add-on libraries. And CSI is really something that's built around identifying the capabilities in the SDK and then doing the right thing. So no dynamic discovery. And that way we can see which features are available or not. So you could have DSP APIs, even if there's no DSP, and you get different performance characteristics out of that. And that's really the layering that we're aiming for with CSI, so that you can move the code between the different implementations and leave the implementation details to the SDK vendor.
Yeah, I mean, one of the areas I was particularly interested in was vector support, through the DSP interface. So if anybody got an interest in that, maybe that's an area we can standardize on.
Vector support for embedded is generally, given the amount of flexibility that we have, an interesting question, because it means discovering the capability on that core and then generating the right code.
And just one other question while I've got the mic.
Yeah. Just to say, my background is DSP, and my feeling about DSP APIs is they're even harder to find than the other things that we're looking at in this. How it's, I think we did one in my previous role, and it didn't end up getting used by people because, the amount of, people always just want to do something different, slightly different from what we've implemented. Yeah.
Well, the good thing is that we have somebody who knows already what mistakes to avoid.
Yeah. Especially fixed point. Floating point DSP library functionality is quite easy, BLAS and things like that. But as soon as you look at fixed point, you start just worrying about, I need scaling all over the place to maintain that trade-off between quantization and number range, and so it all gets very specific, and it completely changes if your word width changes, and it's very difficult to sort of standardize.
Yeah, no, I agree with you. And all different applications have different requirements in terms of accuracy and things. So, yeah, the other follow-up was in terms of the configuration information. Isn't that already covered by the debug team? Aren't they already doing a configuration structure for
configuration? Configuration is actually out in the discovery, and they are basically a provider to what CSI does. So we have those multiple layers of discovery information, one of them being dynamic, but you can also use that information out of band or even retrieve it from out of band into an SDK. So the goal here is that all of these initiatives eventually meet in a single fixed point again and magically work together. It's going to be an interesting journey to actually make it work together. But I think it was in April in Paris when at the spring event that we briefly discussed this, that discovery information is actually an integral part to CSI. And CSI is going to be one of the first big consumers of this.
Okay, thanks.
Any other questions? We have about 4 minutes.
I thought we had as much time as we wanted.
I thought so too, but I was incorrect. We will actually have one priv after this.
Just out of curiosity, I saw on the one slide about cache management, and just curious what you're looking into there, because the cache management extension was ratified not all that long ago. Are you looking at something above and beyond that?
No, I was really just referring to a C interface to the CMO instructions, nothing more than that. Yeah.
Okay. Thanks.
Some of those things are pretty simple that were on that list. Yeah.
Well, as soon as we have the dynamic discovery, the discovery of the actual cache block operation sizes.
As of today, the discovery group is actually configuring structures limited only to discover extension, no parameter, nothing. So just to be aware, this is not a silver bullet.
Yep. I mean, on the IVA side, it's easy because the profiles are standardizing this, fortunately. But on the embedded side, we will have to discover this and then generate the appropriate code. So in other words, map back from the target processor to selecting the right options for the toolchain or the right libraries. So I think we have time for another question or two.
Is a binary distribution a concept in this space?
Not in RVM-CSI. So RVM-CSI is intentionally designed not to focus on binary distributions because we might not even have the same X length, register length. So this microcontroller, this deeply embedded space is the Wild West when it comes to what the API, or not what the API, what ISA extensions we're providing. And I think this is also reflected pretty well in the way that there's no RVM profile coming out, but only RVA profile, so only for application processors, given that it's impossible to standardize what microcontrollers are going to be. Whether they are going to be 32, 64-bit, have multiplication instructions, have divides, so they can be pretty much any mix and match out of the various extensions we have and custom extensions.
Anyone else?